Hi, this is Elias, and we have another question that's come in from Reddit. Let's take a look at it together. Today's question is not equal to comparison of string faster than doing a double equal to? So in other words, if we are trying to compare two strings, what's going to be faster? Seeing if they're not equal to each other or seeing if they are equal to each other? Well, in order to find out, I decided to take this into our favorite tool, .Peek, and see what happens. Well, let's take a look at the sample program that we've got. So we're back to our old friend console app 5, and we've got our static main. We have two if statements. If string 1 is not equal to string 2, then we write out not equal. And then we also have another call, if not string1.equals string 2, because I was curious. I wanted to see if there's any difference between using not equal to in this first line on line 15 versus on line 20. What would happen here if we just use .equals? Is one faster than the other? If we run the program, we'll see that it produces the same result. It says not equal 2 times. No big deal. So we know the program works. Let's go into .Peek and see what is going on. So I will open up the program here and we'll take a look at the compiler, at what the compiler's given us. We see for the first time in this video series that the compiler has given us pretty much the same code that we wrote. And this makes intuitive sense. There's not really any major optimizations that the compiler can do here. And we see that we preserved our not equal to, and we've also preserved our string1.equals. So the code is relatively the same. But what about the intermediate language, or the IL, that gets generated? Well, as it turns out, there is a slight difference between the two implementations. For instance, in the first version where we're doing the inequality operator, we can see we do a function call to op inequality, store that result, and we branch if false down to line 21. Otherwise, we write out our console write line not equal. But down here where we're using string.Equals, check this out. So we load up our two strings, string 1 and string 2, onto the stack. Then we call string.Equals. Then we load the value 0 onto the stack, and we compare if the two are equal. So in other words, we compared to see if the result returned by the string.Equals function is equal to 0, Boolean false. And we branch if equal to false down to line 44, or hex 44, excuse me. Otherwise, we load string not equal, and we print it out to console. So it turns out, if we're searching for inequality using not string.Equals, we actually have one more call that gets introduced here. Now, whether or not this will actually make a difference when the code is compiled down, probably not, because this is going to be turned into machine code at some point on whatever architecture you're running on. This probably won't make that much of a difference. But what about in the string? What about in the string class? Is there a difference in speed between the inequality operator and the string.Equals? Well, to answer that question, let's compare string.Equals and the equality operator first. So in .Peek, I've expanded the string class. So this is an MS core lib. And the first thing we're going to do is take a look at the equality operator. So check this out. Our equality operator, I'll zoom in a little bit here. What it does is call return string.Equals. We're calling a static method and passing into that static method our two parameters, string A and string B. Well, let's scroll up into our methods here and take a look at string equals. So in string equals, if the two object references are exactly the same, two object references, I thought string was a value type. No, string is a reference type that acts like a value type. Anytime you make a modification to a string, you're creating a new string. But in memory, these are reference types. They live on the heap. So they are objects. So if these two object references are the same, then we're dealing with the same string. We're comparing itself to itself. If either of the strings are null or either of the lengths are different, then we know that our string is definitely not equal. Null cannot be equal to something that's not null. If the lengths are different, strengths. Lengths are different, then we know we have two different strings. Then we call this string.Equals helper. Well, let's take a look at what this does. So equals helper is a private static method. It's also marked with unsafe. Interesting. And if we look here, the IL is a gigantic jumbled mess. Oh my God, we're doing pointer dereferencing. There's a whole bunch of stuff going on here. Basically, we go through and see if the two strings are equal. This is where we run our actual equality comparison code. Isn't that fascinating? So both string.Equals and the equality operator both end up boiling down to call this equals helper function. But what about the not equal to operator? Well, as it turns out, the not equal to operator just calls string.Equals and then negates that result. So we see that the equality operator calls string.Equals and the inequality operator calls string.Equals and negates the result. Which one should you use? Which one is faster? Both pretty much call the same code, so really 6 of one, half a dozen of the other. In your case, it's probably better to benchmark and see if it's going to make any measurable impact on your code. If you're only checking for equality once or twice in your program, optimizing and trying to squeeze the last couple nanoseconds out may not be a good investment of your time. Instead, maybe you're dealing with a program where you're looping over strings hundreds of thousands, millions, billions of times, and you need to see if they are equal. Well, it makes more sense to test and see which implementation takes less time on the platform that you're targeting. Which one is faster? For 99% of the use cases, you could use either string.Equals or the equality operator. They're both going to pass into string helper's string equal helper, and it won't really make a difference. For your code in your line of business applications, just use whichever one makes the code more readable. Anyway, that's it. That's all I've got for today. Exciting news. I've actually decided to move these videos to a new channel that I've created called Elias Explains. So if you've ever been interested in the internals of computers, or you've ever been interested in how C# works, or any topics like that, please come over to my new channel, Elias Explains. Link in the video description below. Thumbs up, subscribe, do all that good stuff. Let your friends know about it. That's a new channel. We want to grow it. So just thank you for watching, and we'll see you in the next video.